But now imagine that instead of measuring the speed of the cab, you have a radar sign that measures the speed of the light coming off its headlights. That sign would measure the light traveling at an astounding 671 million miles an hour. Now, when the cab starts moving, you'd think that the speed of the light would increase by the same amount as the car. After all, you'd think that the moving cab would give the light an extra push. But surprisingly, that's not what happens. Our radar sign, or any measurement of light speed, will always detect light traveling at 671 million miles per hour, whether the cab is moving or not. But how could this be? How could all measurements of light speed always come out the same?
If you're running at a wall, it's coming at you faster than if you're standing still with respect to that wall. But that's not true with light. The speed of light is the same for everybody. That's really extraordinary.
So here's how Einstein made sense of this extraordinary puzzle. Knowing that speed is just a measure of the space that something travels over time, Einstein proposed a truly stunning idea: that space and time could work together, constantly adjusting by exactly the right amount, so that no matter how fast you might be moving when you measure the speed of light, it always comes out to be 671 million miles per hour.
To respect that absolute quality about light, time had to cease to be absolute, space had to cease to be absolute, and those two had to become relative in such a way that they slosh between each other.
If space and time being flexible sounds unfamiliar, it's only because we don't move fast enough in everyday life to see it in action.